All right, welcome back to this Delta Solution, and I am joined again by Charles Tan, and we are going to look at Databricks and how that works with DeltaStream. How you doing, Charles?
Good. How are you?
Great, thank you. I suppose we should just dive into this. How are we going to utilize DeltaStream to process inbound or streaming data and land it in Databricks?
Okay, sure. I'll share my screen. So yeah, this is the DeltaStream website. What we're gonna do is we basically have page visits data coming in. What we want to do is we want to downsample it. So we're going to just count the number of page visits over a specific time window and write those as rows into Databricks, as opposed to all your individual page visits being individual rows in Databricks and then having to do that aggregation on the Databricks side. So let's
Okay,
get
so that
started.
yeah,
Yeah.
that should reduce latency significantly, right? You've got it there, it's already processed.
It saves a step that you would normally have to do on the Databricks side. If you don't need
Mm,
it, then this can be something that's done on the fly before you load that data into Databricks. It'll save you on your Databricks bill
Pew side,
and,
yeah,
yeah,
makes
and
sense.
storage, but yeah, mainly the compute.
Oh yeah, storage. You're not saving all that extra data.
Exactly. So here I've just clicked on the workspace. This is basically where we can write our SQL commands and we can inspect the different data Delta Stream objects. So
Mhm.
what I've done is I've created a database. You can create databases this way. This is going to be a place where we'll have our Delta Stream objects land in here. As you can see, I have my default database, my default schema, and I also have my default store. So here I'm pointing to the Confluent Cloud Store. This is just a Confluent Cloud Cluster that I brought up on my own, and I just have a single topic. You can take a look. This is page views.
Okay.
I have one topic in my Confluent Cloud. This is what we're going to be using for this video. So when I print it, you can see
User
what this
ID,
data kind of looks
page
like.
ID. Okay.
Exactly.
And you're going to aggregate across user IDs, or what was the plan?
Yeah, so I'm actually going to aggregate using page IDs. So I want to see
Oh,
if you think about
that
this
makes sense.
data, it's like, yeah, at this time, this user visited this page. And I want to figure out for a particular page, how many visits did it get in a slice of time?
Ah, okay. Oh, that's a good one.
So let's take a look here. The first thing that I need to do is I need to create a stream. This is basically describing the topic that I have in Confluent. I named the stream the same thing as the topic called page views. It has these three fields: view time, user ID, and page ID. If you remember from the print, this is the same thing. I
Right.
specify the store as the Confluent Cloud Store. My topic is page views. The value format is JSON. The way that it prints in the UI, we kind of show it as a table, but it is JSON. And then I'm
Okay.
also specifying a timestamp, which is the view time. So we use this for event time kind of processing.
Okay. So is that just the name of it, or are you casting it at all? I don't see that you're casting it.
So this is just the name of a field that I define up here. So I have
Oh yeah.
these three, and I just choose basically the view time one because I know that this is the timestamp of when a user visited a particular page.
Got it.
Yeah, so I'll run this. So now what has happened is we created a stream. If I look on my catalog, I'll see that page views now appears. So this is what I've just created. We can
Okay.
inspect it a little bit and see the different fields. We can see the types of the field. And now what we can do is we can even write a query such as like select star from page views.
Okay.
Now this will run this SQL for each incoming record that happens in the Kafka topic. This query will ingest it, perform the necessary transformations. In this case, there is no transformation, it's just selecting. And then
Right.
it'll print the results back into my console here. We can see the data rolling in now.
Oh
This
yeah.
is very similar to the print because it's exactly, as I said, it's just a select star.
Yeah.
Uh, let's say the whole goal was to downsample. So we want to have a window of some sort and some aggregation. So let me swap it out for this query. So here I'm selecting the page ID. I'm also grouping by the page ID. And I'm selecting from page views, but you'll notice I have this window function that specifies a tumble window of size 10 seconds. So the way that this works is there's a 10-second window. Once that closed, a new 10-second window is open and we'll perform the aggregations on that set of data for each window.
Does
The
it,
aggregation, yeah,
it's not a sliding 10 seconds. It's this 10 seconds and this 10 seconds.
exactly. Yeah. If you wanted a sliding, we also have a hop. So you can have a hopping window.
Okay.
There's also, that would be more sliding. So you can also specify like how much do you want to slide? So window size plus how much you want to slide.
Okay.
Um,
Okay.
there's also a cumulative window and a couple others.
Okay.
So let's run this. We're just counting the page visits, grouping by page ID. All right. So let's stop this. So if you take a
Alrighty.
look, you can see the things that we've selected. We have our page
Yeah.
ID, of course, the start of the window and the end of the window. When you have one of these kind of window functions, we automatically bring in the window start and window end as kind of the special fields that are related to that. So you can select those as well, and you can group by them.
Oh, okay.
As you can see, this is 10 seconds. This is at 6:15:50, and then till 6:16, and there's 9 page visits in that window.
Yeah.
We want this data to end up in Databricks. So what we're going to do is we're going to write this into a Delta table and then go update our Databricks Unity catalog to include that new table on the Databricks side. In
Okay.
order to do this, we need to create a Databricks store. As you can see, I've already created it. I have like a few different stores and Databricks stores already here. But if we were to create a new one, or if I hadn't done this yet, you click the plus, select Databricks. You can put your name here, so it could be like Databricks store, which is what I did. Add a URL to your workspace, a warehouse ID for any processing that needs to happen on the Databricks side, app token, and then tokens for your data lake. In this case, we support S3. So we would need like the bucket as well as the access and secret keys. Or IAM. IAM is another way.
Okay. That all makes sense.
All right. So after we connected our Databricks store, you can inspect by clicking on it. Here I have an E2 Databricks catalog. Inside here, I have my Databricks schemas. I'm going to go ahead and create a new one for us. I'll just call it demo.
And that creates it over in Databricks
Exactly, yeah. So this is now, if we went to
from
Databricks,
Delta. Okay. Oh, that's cool.
we refresh this, now demo's here.
Yeah.
And what we're going to do is we're going to, so this is the same select statement that we did earlier. I'm actually going to downsample it even more and put it to 1 minute. And then I'm going to create a table to be the result of that select statement. This table is going to exist in the DeltaStream database and schema, but we're also going to create a table on the Databricks side and add it to Unity catalog using these kind of fields. So E2 demo, and then we expect page visits by page ID test to be a new table that would show up here. And we also need to specify where are we going to write the data. So that's going to be here. This is an S3 location.
Oh, okay.
So this all looks good. Let's run it.
So that just
So
created structure for it, or is it feeding the
yeah,
data in now too?
so a couple of things happened. First is those table creations that I mentioned. So you'll notice that this table got created, but also a query was started. And I think this is what you're asking about. We created
Yeah.
a
Yeah.
query
Yeah.
to basically continuously run this processing and write the results over here. Yeah, it's something that's going to be long lived in the sense that it's always going to be ready for the next event to come in. If we look at our queries, this tab, we could see a list of all of our queries that are running. Since we're in the business of stream processing, these are going to be long-lived queries.
That makes sense. That's current. That's running. That's the values of what the query is. Okay.
Yep. And you can kind of inspect things from here. It takes a few moments for the query to actually transition to the running state, since we're bringing up something that's going to be basically a cluster for our query to run.
Yeah.
Okay, so after I refresh, I can see that the query is now running. So I can expect that this means that data is being written into my new Delta table.
Okay.
I can double check by going to S3. Here I've got my DeltaStream bucket test, and I can see Parquet files landing here. I know it's this
Oh,
path
yeah.
based on the query I ran. If you remember, I specified the path here, so that's what I'm double
Oh, yeah.
checking.
Okay, so that's the raw data without the Databricks presentation layer.
Exactly, yeah. So this is a raw Delta table. All of the things related to the Delta table exist right here. The metadata is in the Delta log, and then of course the Parquet files are the actual data. Another thing that we
Okay.
probably want to check is back on the Databricks side. We want to make sure that our Unity catalog is updated. So
No?
here you'll notice this table got created.
Yeah.
This matches what we expect based on the query we ran, and
Yeah.
we can sample some data. Okay, great. So as you can see, we have 1 minute time windows based on the window start, window end for particular page IDs, and we're counting the number of page visits that occurred in that time.
That's really
On
slick.
Yeah, we can also check on the DeltaStream side. If we inspect our Databricks store, we can see that the table is updated here, and we can print and get similar feedback from what we get in Databricks itself.
Oh, that's cool. Yeah, doing that in flight really is going to reduce your storage and compute costs at the other end and latency.
Yeah, this is kind of along the lines of that shift left pre-process data where you can, instead of introducing batch jobs to do those transformations, which incur latency, extra overhead for the orchestration, as well as the cost, like you mentioned.
Yeah. Well, that's really cool. Is there anything else to this, or is it really all that simple?
And that's it. Yeah, it's just as simple as a few queries.
Nice. Well, thank you so much, Charles. I appreciate you taking time to walk us all through that.
Okay. Yeah, no worries. Thanks, Sean.